Hi, colleagues. I'm Peter Meyer of BLS. I'm co-chair with Lisa Freehill of the Government Advances in Statistical Programming, or GASP conference this year. The detailed conference program has all the abstracts. You can see a QR code to get to it on screen here, and we will post a link to it in the chat box. We hope to have all the presentations up online on our website within weeks, but please email me if you specifically need something faster, and I can send it or put you in touch with the speaker. We have many interesting speakers today, and we'll be running speedy sessions with the same format as yesterday. Regular talks have 12 minutes, and lightning talks have 6 minutes each. Attendees will be muted. Please post questions to speakers in the Q&A boxes if you can. The Zoom chat box is also open for conversation, but remember that 100 people will see those posts. And we're showing 2 Jamboards open where you can post a virtual Post-it note to list job openings or upcoming events. We will reshare all these links in the Zoom chat box during the day. If you have any administrative questions today, please contact me and Lisa by posting to the Zoom chat box, or send private messages to us, or email us. We're getting terrific support from the ASA and from our FCSM computational statistics co-chairs. So if you have a reason to message the other people in the general panelists, Nathan or Wendy or Donna, they would help too. Okay, our first session chair is Brandon Kopp. Are you ready to unmute, Brandon?
I am.
Okay, you're in charge.
All right, thank you. And welcome everybody. I'm Brandon Kopp. I'm from the Bureau of Labor Statistics. I'll be chairing this first paper session entitled Promising Practices. As Peter just mentioned, each of these talks is going to be about 12 minutes. And for the speakers, a reminder that I'll be enforcing that. You'll hear something from me about 1 minute left. With 5 talks, that gives us about 20 minutes at the end for questions. We will be holding all questions till the end, but I encourage you to submit your questions to that Q&A feature as you have them. Don't try to remember them at the end. Submit them as you have them. I'll be curating them and I will ask them of the speakers at the end, or the speakers are welcome to get into that box and answer questions as we go along if they feel so inclined. With that, we'll go ahead and get started. So our first presentation today is going to be from Jun Yan from the University of Connecticut. And so yeah, with that, go ahead and take it away.
Thank you, Brandon. My title is on principles for government open data curation. This is a case study with the New York City 311 service requests. My co-author is David Toucey, and he happens to be the former executive director of NYC DOIT, which is the department that implemented the NYC 311 request database. I will start with a brief introduction. New York open data is viewed as a right for all. There are many reasons for data, especially government data, to be open. And there are many cities who have led open data efforts. Over 50 cities have formal programs on open data. And NYC is one of the forerunners after the 2012 open data law. Today, NYC Open Data has over 3,000 data sets from 98 agencies, and they are all accessible online. And the data sets have been used by many researchers on many topics, such as health, smart city, transportation, among others. Specifically, the NYC 311 service requests dataset is the most viewed dataset among all the NYC open data. It's the NYC 311 is a unified frontline for all service requests to NYC government agents. This dataset was used in my intro to data science at UConn this year, the past spring. My students presented in the March NYC Open Data Week on their works. In this presentation, we used data in March 2023. We downloaded all the requests in this time frame, and which consists of over 250,000 records. And we are going to discuss some data curation issues for this, using this data set as a case study. And specifically, we are going to talk about data validity and data efficiency issues. First, let's look at this data set. This is the data is available in a CSV format, and we read the data into R, and we made some cleaning about the the column names, because the column names has spaces in them, and I don't like spaces in names. You can see here we have over 251,000 rows and 46 columns. Interestingly, in the data dictionary, only the first 41 columns were documented. So here you see the last 6, and then the last 5 of them, these were not documented, and we only have a name. And actually, you will see these data are of particularly we have issues with them. This is a quick summary from the data frequency. We can see, well, most of the requests were for NYPD, HPD, that's Home Preservation and Development, and DOT, Department of Transportation, and then Department of Sanitation. We first looked at the missing data for character or characteristic columns, and missing data can be of different forms. It can be just either a blank or unspecified or unknown. And we looked at all the character columns, and this is a summary, and we looked at the top the columns with the highest number of blanks or unspecified or unknowns. You can see, well, there are, for these columns, vehicle type, there are taxi company borough, there are so many rows that are just blank for these columns. And this is, and you can see this is probably because some of the columns here only applies to a small portion of the requests. For example, vehicle type, this doesn't apply to any other complaint type like noise complaints, or this bridge highway direction, bridge highway name, and these complaints, these columns only apply to complaints that are probably from DOT. Among the numerical columns, there are missing data like, well, the number of missings is much less, right? And zip codes, boroughs compare, this is minor compared to the total number of rows, about 251,000. Now let's get to look at some of the examples of invalid data. We first look at each row, each request has a created date and a closed date. And interestingly, there are some requests, there are actually exactly 8,700 requests whose created date and closed date are exactly the same, down to the second. And there are also, well, this table shows, yeah, what are the agencies that have provided this kind of data, right? Exact same date for closed and created. So among them, the DOHMH, this is hygiene, Department of Hygiene and Mental Health. Next, we looked at, well, we also looked at, there are some requests that have created date not equal to the closed date, but well, it's bad because the created date was later than the closed date, and they are all from DOT. And among them, we learned that recently that some of these requests, they were only recorded, entered into the system in the next business day because it was handled, I guess, after the business hours. But still, that and this at this end, right, over 3 business days, the created data was behind. So there are still things we don't know yet. We have contacted the NYC 311 request data maintenance people. Hopefully we can find out more. The next invalid data we saw, we looked at was about zip codes. And there are 2 zip codes field. The first one is the incident zip code. And this one, there are, well, compared to 251,000, the invalid zip code number is very small. There are some blanks, 2,600 blanks, and there are these many these are just invalid zip code. The other zip code field, this is one of the last 5 that was not documented. And this one actually look at, compared to 251,000, most of them are invalid. We checked the zip code of the New York City, and then most of them are invalid, and we still don't know why. For the field of borough, right? New York City has 5 boroughs: Bronx, Brooklyn, Manhattan, Queens, Staten Island, and this borough field here, they are all valid. They are all valid. But there is another field called borough boundaries. And borough boundaries are, well, this is just they coded the field in as 1, 2, 3, 4, 5. And then when we recode this, right, code it back to oh no, this is about invalidated. Then this field here, Park Borough looks like there's nothing invalid. But interestingly, we will see this is a redundant field. Okay, so for open data channel, these are there's some channels that are just unknown. And this actually doesn't make sense because from my co-author, by design, we should all know, all the channels should be known. And then this seems mostly of these unknown requests they are from DOT and DOB. All right. We checked some additional variables like precincts, and a lot of precincts are invalid. Okay, here comes the redundancy part. We looked at these 2 boroughs. One is borough, the other is Park Borough, and they are all the same. They are all the same. And we also look at this borough boundaries. And after we translate this, recode these numbers back to the characters, and there are only 175 that didn't match. So 3 borough columns, mostly they are the same. And we also have this, right? Latitude, longitude, and location, which is a combination of the other 2. And so location is a redundant field. And agencies, agency name, right? In the data set, they stored both agency, an acronym name, and the full name, which takes a lot of space, all right? And cross street and intersection street, looks like many of them are the same. Some of them, it's missing in one, and there's some records that are missing in the others. But for those that are, those rows both are not missing, many of them are the same. After we remove this extra spaces, right, after they are all the same.
About 45 seconds remaining.
Yeah. All right. So to summarize, we have there are some spaces we can improve on this data set. We can improve the data dictionary, we can impose validity check, and we can improve data storage and transportation efficiencies. That's all. I stop here. Thank you.
All right, thanks so much. And again, I just want to remind everybody that as we're going along, feel free to put your questions into the Q&A feature, and we will follow up with those at the end of the talks. So next up, we have David Corliss from Piecework, and he'll be talking about identifying and mitigating bias in machine learning and AI. Oh, you're still muted, David.
Thank you. Good morning. Good morning, good afternoon, good evening, wherever you may be. Let me share my screen, and we can get started on this. Want to make sure everyone can see my screen properly. And this is a little bit of information on myself in case you're wondering who this clown really is. All right, then we will dive in. We're going to be talking about bias in machine learning and AI. I think a number of us are familiar with the concerns and issues around this. The real thrust in this particular talk is going to be on how to measure it, how to identify it, how to take action against it, and in particular, the most important word here is first, design against it. So what we're going to be talking about is not waiting until we're down the road, something has been released into the wild, working for the public, and there are a number of issues that result, but rather making as part of the standard development process. We all test our code. We're all going to do code walkthroughs. We're going to look at a number of different things, and we're going to do peer review for a lot of our work. What I'm encouraging is that measuring bias become part of the development process, that we design against it rather than merely respond to it. So let's look at how we can do that. Now, of course, in many cases with AI and machine learning, the idea of these algorithms was to take the human element out, because we know that humans can have our own particular biases. That if we can take people out of the picture, that's supposed to make things more fair, right? It often hasn't worked out very well, has it? So we have to ask ourselves what went wrong. So let me look at, start with a couple of examples of machine learning algorithms that have run into problems. In this case, we've got a machine learning algorithm, such as there are several, but such as the COMPAS algorithm, which sadly is still in use in a lot of places. In this case, we're going to look at an algorithm that decides who gets bail, who gets parole. It's a recidivism algorithm. We saw something similar to this in one of the lightning talks yesterday, only that was a much better algorithm. This algorithm has serious problems. And so we've got this COMPAS algorithm. And the idea is it's supposed to take bias out of the system, but what was found was it actually ended up recreating the exact same bias it was supposed to eliminate. And we can see some of the reasons why. We'll go into this in a little bit more detail in a moment, but you look at the factors that go into the bias, the factors that go into the algorithm are themselves subject to bias, in this case, racial bias, age at first arrest. If you're looking at a 12, 13, 14-year-old kid, and does he get taken to the principal's office? Does he get, given a stern talking to, or is he actually arrested? Since there's bias in the predictors, well, we're going to talk about that in just a minute. Another good example, and this is sort of a good news, bad news kind of thing. In this case, Amazon. Now, this is according to reports of Reuters. Amazon has, as a corporation, has made a statement on this. Amazon has said nothing about this based on newspaper reports from the British news agency Reuters. They're going to use a resume to pick use an algorithm to pick the top resumes. The idea was pick the top 5% of resumes, hire them, and then all your hiring problems are solved. Well, AI isn't magic, is it? We don't know how the algorithm worked. In this case, is using natural language processing, and there are a whole lot of different words that can show up in a resume. The concern was that previous hiring practices had been biased against women. But when they implemented this algorithm, they found that the algorithm had been trained to be biased against women applicants. To Amazon's credit, they ran this test before they did what you're supposed to do. They tested for bias before they moved it into production, found there was bias, and did not deploy it. So let's look at where bias potentially can come from. One example is when we've got the root cause of bias is in the data that we pull in. in this case, selection bias. We train the algorithm based on bias subsets. For example, in this particular case, this is Alex Najibi's work out of Harvard. He's looking at the accuracy of facial recognition methods and found that for females, for people with darker skin, the accuracy of the facial recognition, this is from a number of leading facial recognition applications from a number of leading providers, and found that that certain population subgroups were less accurately identified. This can result in some serious concerns. In this particular case, we're looking at Project Greenlight. In this case, this is something that was set up in the city of Detroit. I'm near Detroit, and they set up cameras at stoplights to take pictures of people running stoplights, that kind of thing. And it turned out that when we looked at Najibi at Harvard, found that when you look at where the cameras were placed, and you look at where the when you look at the Census Bureau data, there's a match for race from where the cameras were placed and the racial demographics of the neighborhood. And so what we have is, in both cases, whether it's the facial recognition and then the application, we get a disparate impact. And we get a disparate impact because we had a biased training population, and that resulted in biased results. Now let's look at a couple of, let's look at another one. I'm going to call this the history problem. In this particular case, the idea is that machine learning is supposed to replace human decision-making. However, there's a problem in that the algorithm is trained from earlier, previous biased human decisions. And what we end up doing is we simply train the algorithm to repeat the very bias we're trying to get rid of. This will happen when we train the algorithm based on earlier decisions, and those decisions were biased. Now, I'm going to call this a history problem. You're reading the literature, you're going to find a different name. You're going to see this most often called prejudice. This isn't necessarily prejudice. Prejudice certainly falls in this category, but there's some things that apply to this particular problem that aren't actually deliberate or unconscious prejudice, but simply that you're using previous human decisions, and that when the training data set was biased from the beginning, the labeling of the data set was from previous decisions, the only thing you're going to train the algorithm to do is to repeat what the people had done in the past, and that's the very bias you're trying to replace. So this is one thing we're going to be watching out for. Again, in the literature, you'll usually hear this called prejudice. It applies to situations where, you could, for example, you do this for manufacturing, and you look at stuff coming off an assembly line, and people quality check parts, and then you've got an AI to check for the parts, and if you label the data based on, see, this is not a prejudice kind of thing. Nobody's prejudiced against this part or that part. So I'm going to call this the history problem. But you look in the literature, you'll call this prejudice. Another root cause of bias is something called the spaghetti problem, and it's perhaps best described by this picture. Once upon a time, libraries had dictionaries that looked like this, that had tens of thousands, maybe 80, even 100,000 different words. In this case, the concern is that there are thousands of potential predictors. And then when we process these, it's often found in natural language processing, but not entirely. Think about genetic testing. There's an awful lot of genes and levels of gene expression. And so you can easily run into thousands, even hundreds of thousands of potential predictors. In this case, there are many, many predictors. And then here's the critical step in causing the problem. The algorithm takes as a predictor uncritically anything that sticks. If it looks like it's predictive, we're going to use it. Now, if you look at, just as an example, the Amazon algorithm, it did two things. One, it rated resumes based on how people had rated them in the past. That's a process it was trying to improve on. But the training data set was biased data, because of just what people had done. Also, it had grabbed a hold of anything that looked predictive of the previous bias decision, anything that looked predictive without individually screening the predictors. Now we're getting into how we design against bias. When we've got this long list of predictors, I'm sorry, folks, but we're going to have to look at those predictors, give you an example as appropriate to the Amazon case. Turns out They were concerned that it could be biased against women. They wrote the algorithm. The algorithm was biased against women. In the algorithm, according to the Reuters reports, you lost points in how high your resume was rated if the word softball showed up in your resume. Now, how many men play softball in college? How many women play softball in college? So in this case, there was a biased predictor, biased predictors in, biased out. So here's how we can measure it. This is an important tool. Now, this is not the result of an algorithm. This is from COVID-19 in initial mortality. This is a public health study, but here's the thing, this very well-established practice in public health study. This is how we can measure bias. We're going to use the same technique with this solid science. How do you look at bias in this particular case? We've got U.S. counties by quintile, counties with a high percentage of BIPOC, also at higher initial mortality. And so in this case, we're looking for factors that are disproportionately represented, often in some marginalized population. We're going to borrow this technique from public health. We're going to apply it to algorithm performance, and we're going to use the same methodology of disparate impact. We can use log odds. We can use odds ratios. From my personal experience, that folks are using that log odds are really good for in academic journals, but in dealing with the public, in dealing with governments and legislators and administrators, odds ratios or elevated risk percentages are often much more effective than odds ratios. So when we look at designing against bias, one possible technique is to have a second algorithm. You take all the factors that you have and build your initial algorithm, remove from it any possible factors that might be implicated, run an algorithm there. This won't necessarily perform well, but it'll allow you to evaluate against this baseline, allow you to evaluate how much a bias is present.
About 45 seconds remaining.
Very effective technique, fair learn algorithm. It creates confusion matrices, and this particular package is open sourced. Very, very effective at measuring bias. This is, if you're measuring bias, fair learn algorithm, open source in Python, definitely something you'll want to see. So summarize best practices, parsimonious models where possible, screen predictors for bias. A couple of things here. Black box models, other people have talked about that. Test for bias, we can use fair learn, we can use a comparison algorithm with bias removed. And we're going to open source the data and the algorithm. If we get, the more we get away from black box and let other people check how well the algorithm is doing and potential sources and results for bias using disparate impact, the better our results are going to be. References and questions are for later. Thank you.
All right, thank you so much. And just a periodic reminder for everybody, if you have any questions, please put them into the Q&A feature and we'll be answering those at the end of the session. And then next up, we have Benjamin Schneider from Westat, and he'll be talking about developing documented trustworthy R packages for official survey statistics. So take it away.
Great, thanks, Brandon. Oh, it says I need to, the other participant needs to end the screen sharing before I can share. Oh, thanks, David. Okay, so I'll share these slides. All right, can you see the PowerPoint slides now?
Yes, we can.
Great, thanks. All right, so good afternoon. Thanks for joining the session. I'm Ben Schneider. I'm a statistician at Westat. And I'm excited to talk to you today about the process of taking your cutting-edge statistical software and making it into a documented, trustworthy R package fit for use in official survey statistics. This talk is informed by recent work on R packages for surveys, especially the Surveyor package, and recent Westat packages for weighting surveys and conducting non-response bias analysis. And one of the things that's fulfilling about working in official survey statistics is that our work can lead to meaningful improvements in government programs. But with that opportunity, there are special requirements we have to consider for our software. First, we have to use software with clear, transparent documentation. And second, it's especially important that we can trust our software. That is, that we can confidently say that it gives correct results today, in the future, and on multiple data sets. One big challenge in meeting these requirements is that a lot of the R programs developed for survey statistics are developed by academics and statisticians who aren't professional software developers. That covers many of us here, including myself. And a lot of the R packages developed for survey statistics are created as proof of concept software developed for single publication or project. In addition, most of us who aren't professional software developers aren't trained in best practices such as unit testing or version control. And often there are gaps in documentation, either in explaining how to use the software or in explaining the statistical details of the methods that the software is implementing. Today, I'd like to talk about some key questions we should think about when working to make our software document and trustworthy. In response to each of these questions, I'll share some strategies that have proven effective in R package development at Westat and beyond. So first, there's this question of how should the user interact with the software? Let's talk about some documentation strategies that are helpful for answering this question. First, you can share your software as an R package, taking your R code and organizing it into the standard R package structure with help pages created as part of that standard package structure. I'll share an example of what a help page looks like for an R package. Here, we're working in RStudio, and we're using the NRBA R package created by Westat, which helps users do things like calculate response rates or conduct various forms of non-response bias analysis. You can see on the left side of RStudio that I've started typing the name of an R function named calculate response rates, and RStudio has provided an automatic pop-up that shows us some information about that R function. And on the bottom right side of the window, you can see this help page that's popped up and explains what our function does. So this is what I mean when I talk about a help page in an R package. So let's zoom in a little bit. Here at the top of the help page, we have a description of the function, its purpose, and a layout of the syntax with function arguments. You have additional details about each input for that function. For example, for this function, to calculate response rates, there's an input called data, that's a data frame. There's an option to use a weights variable. And at the bottom, there's an option to specify the name of a specific formula we want to use to calculate response rates, including APORs, RR1, RR3, etc. formulas. And all of this is documented in the help page. Now in practice, users often don't fully read the help page before running an R function. So it's helpful to provide your users with informative error messages when they do something wrong. And it's particularly helpful to provide constructive suggestions to users about how to do things correctly. So here's an example of an error message for that function that we saw earlier for calculating response rates. Here, I've highlighted in red where the users entered an invalid name of a response rate formula. Instead of entering something like RR1 or RR3, they've said they want to use the quadratic formula for calculating response rates. So we've supplied an error message that tells the user what specifically went wrong and offers a constructive suggestion about how to correctly specify which response rate formula to use. Now, in addition to documenting how the user should interact with the software, it's also important to document what statistical methods are actually being applied by that software. Some strategies that are helpful in your documentation are to cite relevant publications, ideally referring to specific formulas or algorithmic descriptions in those publications, and also providing formulas directly in your documentation itself. We'll look at an example from the NRBA package. Here, on the help page for the calculate response rates function, we've defined the response rate formulas that are actually being used by the function. The help page includes actual LaTeX math that shows the formulas used and breaks it down in terms that the user can easily understand. In addition, the help page includes a references section at the bottom that tells the reader where they can learn more about the different response rate formulas. Finally, another useful strategy is to provide toy examples with our data that users can easily understand and experiment with. For example, for calculating response rates in the NRBA package, we provide an example survey data set with demographic variables like race or sex, and we provide example R code that the user can run to calculate response rates on that data. So here, we show the user how to calculate response rates by combinations of sex and race categories, and the user can play around with that and check their understanding of the response rate functionality. Finally, in addition to the help pages in the R package, you can provide longer form documentation, such as a vignette or a journal article. And for those who may not be familiar, Vignette is simply a catch-all term for R packages to refer to the long-form documentation. And that can be anything from a journal article included as a PDF to a walkthrough or user guide. Here we have an example of a vignette with the NRBA package published on CRAN. We're looking now at the overview page that's on CRAN. It contains several details like the package version, the list of authors, and at the bottom there's a list of vignettes. Here you can see this vignette titled Analysis of Response Rates and Response Propensity. And this is just longer form documentation, including statistical details and explanation of the typical user workflow for the package, and explaining why you would analyze response rates and how to do that. It includes high-level details about your data and specific information about the formulas used in the analyses. So now let's talk about trustworthiness of software, trying to answer these key questions of, is your software giving correct results? And can you trust it to work and still give correct results a year from now? So a couple of basic strategies that are helpful. First, test your R code on toy examples where the correct result is clear to you, and compare the results to other software implementations of the same statistical method. I'll give an example of this in a minute. For this other key question of can we trust the software to work and still give correct results a year from now, a helpful solution is to implement the tests you ran for correctness as a script so that you can easily run your tests later. And I particularly suggest using the test.r package, which I'll provide an example of shortly. So here's a small example of the kind of testing that I've just described. Here we have a short little R script that implements a statistical method. We add two numbers together, X and Y. The top of the script creates that function, and then we test that this function gives correct results in a toy example. We add 2 and 2 together, and then we check that it gives the right answer of 4. And then we also compare our statistical code results from another piece of software. In this case, at the bottom, we compare our function to the McGritter R package, which has a function named add that adds 2 numbers together. So we can see that our results match other software, and we're thus more confident that it's giving correct results. And all of this is implemented as a simple R script that we can rerun a year from now in case something's changed in our software. For the NRBA package, we have about 100 or so of these kind of tests that are implemented as scripts powered by the test.r package. And this lets us run tests for all the different functions in that package in an automated way. Here, we can see that we have tests for the function called calculate response rates, and for other more complex functions, implementing chi-squared tests, t-tests, and other kinds of analyses. We're able to run all of our tests automatically in about the span of a minute, and we get a summary of which tests failed, passed, or produced warning messages. So it's helpful to rerun that test script under several different circumstances. First, when you make updates to your software and you want to make sure that it's still correct. Second, when a new R version comes out, for example, when R version 4.3.1 is released soon. And finally, when other R packages that you rely on get updated. For example, if you're using the popular dplyr package to help you do data manipulation, then you know that that package undergoes frequent updates, and you want to make sure that your code still works correctly when dplyr gets updated every few months. And it's helpful to publish your code as a package and to publish that package on CRAN, because CRAN will rerun your test scripts for you on a daily basis. CRAN will even give you advance notice if there are upcoming changes to R or another package that you need to address in your own package. Here's an example of the daily test output from CRAN for the NRBA package. We can see that this package was tested in the morning on different systems, including Windows, Mac, and Linux. And it was tested on the development version of R, meaning the version of R that's going to be released soon. It was tested on the current official version of R and on some recent previous releases. Fortunately, all these automated tests that we programmed are turning out okay. If our tests started failing, CRAN would give us advance notice so that we can fix the issues before the problem affects end users. So to summarize the top suggestions we've talked about today, first, structure your R code as a package, since that lets you take advantage of many helpful infrastructure tools for developing and sharing your code. Next, leverage multiple documentation formats, help pages, vignettes, README files, etc. And then test the correctness of your software using small examples and comparisons to other software implementations so that you can understand why your code is or isn't working. Now, I strongly encourage automating your tests so that you can be confident that your software gives correct results in the future, and then publishing your package on CRAN with those tests so you can take advantage of the automated testing that they provide to package developers. So I'd like to acknowledge the many helpful developers and co-authors at Westat who've been involved in the work underlying this talk. And for those who are curious, I provide some additional references and suggested readings for learning about how you can document and test R packages. Thanks for your time today. I'll give my time back so that we can hopefully have some discussion after. Thanks.
Awesome. Thank you so much. Okay, so next up, we have Matt Ring from Westat Insight, and he'll be talking about web scraping in Python.
All right. Hi, everyone. My name's Matt. I'm from Westat Insight. I am a data analyst, and today, as mentioned, I'll be talking about web scraping in Python. Kind of a broad overview of what we're going to cover today. We've got some basic definitions that you'll need to know to understand what exactly web scraping is, the benefits, like why you're actually here and listening to this for web scraping, how we implement it in Python, a couple of screenshots of a really, really simple script, the use cases, some of which I've used in my own work, and the limits of web scraping in Python. Definitions. There are kind of two interchangeable things here. There's web crawling and scraping, which are often used simultaneously. Crawling would be what we do when we're surfing the web or clicking on links using Google. That's the traversal of web pages, which we can automate in Python. There's also the act of web scraping itself, which is collecting of usually unstructured text data from web pages. So that would be kind of like copying and pasting, if you will. The benefits of automating these processes using Python are the same as automating a lot of other tasks. There's the efficiency. As opposed to conducting 1,000 Google searches yourself by hand, you can have Python do it pretty quickly and efficiently, saving money and time. It's modular. You can develop web scraping code for one task and pretty easily port it over to another task. I know I've done that previously in some work. And then there's the scalability of it. You can work with 1,000, 2,000, 100 searches, whatever number, and it is much easier to do than by hand. Implementation, this is the first step, as anyone who works in Python or a package-oriented programming language knows, is importing your packages. We've got the mainstay here, which is pandas, but we also have two really important aspects, Beautiful Soup, which is BS4 there, and Selenium. These are going to handle the HTML, the HTTP requests, all of that stuff, the stuff that's unique to web scraping. And note that in Selenium, we're actually importing what's called a WebDriver, which is going to simulate Google Chrome in this instance, though you can do other web browsers as well. When you actually run some of the upcoming code on your laptop or desktop, it'll open an automated browser for you that you can see. I've also noted sleep times here, which can be useful if you're conducting multiple searches and you need to pause. Here's the real core of this code. It is actually scraping the HTML and finding what you need. In this specific instance, I accessed Yahoo Finance's trending tickers page. We just used that URL there. We create an instance of the browser, pass the URL into that browser with just .get. We grab the HTML page text with .page_source, and then that'll give us back the HTML itself. We can throw that into Beautiful Soup as seen below and tell it, hey, this is going to be HTML, because Beautiful Soup can also technically parse stuff like XML. And then we have our HTML document and an easy way to parse it. The Beautiful Soup has a command .find, which will search for different HTML tags. Here, we're specifically looking for tables and a table of the class W100%. This code looks really simple, but it's what's going to change the most when you're developing Python code for web scraping. This can be as complex as, well, this can include searching for other URLs if you're web crawling, to just searching for tables like right here. Then we put this into a pandas data frame, which pandas can do pretty well with read HTML, and we pick out the pieces we're interested in. I scraped this on Saturday, and at the time it appeared that a lot of cryptocurrencies were on Yahoo Finance's trending tickers page, because if you're keeping up with the news, there was a pretty big change in the valuation of a lot of these cryptocurrencies recently, and we can see that in the data that we actually scrape, because there's Bitcoin, Ethereum, and Dogecoin, some very common and well-known ones. Other use cases that are a little bit more relevant than scraping Yahoo Finance stock tickers. File downloads. When I was in grad school, I did a research project where I wanted to see, or we wanted to see, the impact of upzoning on demographic change in DC. And we had these things called planned unit developments that would impact the nature of a neighborhood, how many housing units were there. The issue is we didn't know exactly when they were implemented, but those were present and publicly available in the DC Office of Zoning's transcripts and orders. So we developed a web scraping code to go through, download these files, and then we could actually scrape through the files and look at the decision as an example is shown below, which luckily for us, kind of the legal language or the meeting language was very, very specific and constant. It would tell us, hey, it was approved on this date, usually, or there was a date in the transcript name. Second, and kind of the overarching theme here is you can conduct searches like Google searches, Firefox, DuckDuckGo, whatever you want. And for results of like 100,000, not 100,000, we were requested 1,000 searches from LIHEAP, the Low Income Home Energy Assistance Program. This would have been really time consuming. It would have been horrible for a whole bunch of RAs, but we were able to automate it and store it in a table that was easier to go through. And we could see that, hey, like LIHEAP showed up when we searched State of Alaska Heating Assistance Program at the second and third websites. We can also compare sites based on text, because we've scraped that text, and a lot of people at this conference have discussed different NLP methods. This can provide the data for those methods, or even just simple similarity scores, like we've done in the past. It can provide a more objective way of comparing websites too, or at least a quick and dirty objective way, like Jacquard similarities. So Facebook's login and Twitter's login would probably look very similar if we were comparing them. There are also quite a few limitations of web scraping, which I'm going to discuss here. One of the first ones that pops up is site mechanics, which actually relates to pop-ups. If you see like a little chat bot in the bottom corner of a web page, it's not usually HTML, it is JavaScript that's running there. And Selenium can run that, but not all of the time will you get the actual text from it. So other little bits and stuff that pop up on web pages in JavaScript might not be a web script. If a website updates, for example, Google has changed a little bit since it coming on the scene in 1997. And when a website structure changes, its HTML changes, and you're going to need to update your code, or just use an API. That'll get you to the background data that you might be looking for. Subjectivity. Browsers, the different browsers, and your own personal location and time will impact what's returned to you. For example, here, I searched Insight Policy Research in Google and Bing, and the second result was different. We see a LinkedIn page versus the Our Story page. There's also the personalization, as I just briefly mentioned already. Stuff like location. For example, when I search hospital, I get Virginia hospitals, but someone in Texas, Michigan, California, they're going to get different results. Same thing with the date of search, or even your search history, I believe impacts Selenium's results because it, I think, still relies on cookies. Don't quote me on that. Finally, and probably most importantly, is the permissions and legality of certain searching. I am no lawyer. I'll put that disclaimer out there right now. But these are issues that other people have run into, and you should really strongly consider if you're going to look into web scraping. If possible, use an API, because then you're not going to be dealing with any of these issues. First and foremost on this kind of checklist I've made is it personal data? If you even think it might be HIPAA or COPPA related, for example, some federal statutes, don't scrape it. I feel like that goes without saying. Copyrighted data, if that's in question, do not scrape it. And if it's behind a login, that's actually the case that's shown on the left on the timeline, Facebook versus Power Ventures. They were making this better UI where you could have a variety of social media sites in front of you. But Facebook claimed it was a hacking or a phishing attempt because they used the login to scrape the data from people's pages. The people provided it to them, but it still caused issues. If you're going to hurt the website, if you're running a whole bunch of web scraping all at one time and like damaging their like server side functions, that's a problem. That was the earliest case that I have listed on the left here, eBay versus Bidder's Edge, in which Bidder's Edge was scraping eBay 100,000 times a day, I believe. And so eBay filed a lawsuit because it was slowing down their whole website. So if you're trying to scrape eBay 100,000 times, probably don't do that. And then fifth is a bit of a catch-all. How are you going to use these data? If you're trying to recreate a data set or a web page that someone else has, you probably shouldn't be doing that. Quick recap of everything that was covered. The benefits of web scraping are similar or kind of synonymous to other forms of automation: efficient, modular, scalable. Implementation relies heavily on Selenium and Beautiful Soup, which makes it very, very simple because you just use these packages and they've done the rest of the work for you. Use cases always rely around data collection and usually text analysis, although, for example, with my Yahoo Finance example, you can scrape tables too. Some of the limitations are going to be based on mechanics and subjectivity. And importantly, you should go through this checklist of personal, copyright, login, the rate at which you're going to web scrape before going forward. That's the end of my presentation. I'll return a little bit of time. Yeah, hope you enjoyed it.
All right, and thanks so much. I'll put out my last request for questions. So again, if anybody has any questions, please enter them into the Q&A feature. And I love what people have been doing so far. If you have questions for a specific speaker, please note that in your question. That would be ideal. And so with that, I'll turn it over to our last set of speakers to talk about UI design patterns for code reuse.
Great. Hi, everyone. My name is Wei-Huang Wong, and I'm here today with my co-presenter, Keegan Rice, to talk about UI patterns for code reuse. The one-sentence summary of our talk is that if you want to enhance the reusability of your code, you should think of it as an application. That means you should think of the users of your programs as users rather than developers or programmers. So in a sense, our talk has pretty similar motivations as the talk that Ben gave earlier in this session, but just taking a bit of a different perspective. Now, when I say program, I mean anything from an analysis script to a program to automate report production. As programmers, we often focus on creating well-engineered programs. We follow principles like don't repeat yourself and other best practices from software engineering handbooks. But what if instead we wrote programs that are like well-designed apps? So think about the last time you used a good app. You knew how to use it without reading a user manual because things were placed where you expected them to be and the app guided you to achieve your desired outcome. A good app understands that users may not be experts and takes pains to be helpful to users. Why do we want to do this? In addition to being more user-friendly, we think user-friendly programs reduce transition costs when handing over code to other teams and analysts. They also constrain a way in which code is exposed to users, and in so doing improves reproducibility. So let's start with a motivating example to fix ideas. Imagine that you're an analyst and you're asked to write a program that creates statistical tables. Your program reads in some data, does some data wrangling, computes some statistics, does some more stuff, and then populates the table shell with these statistics. Now you're asked to add some features to your program. So let's say you're asked to create both a simple version of the analysis that reports only the conditional means in some cells, as well as a version that includes more statistics like standard deviations for QC or for diagnostics. Let's also suppose you're asked to suppress statistics in cells that have counts smaller than some threshold. So you modify your program and you add flags to your program to toggle between different versions of the output. And because you're a good analyst, you painstakingly document your program, and your instructions might read something like change the path to the data you want to analyze on line 15. If you want to show only means, set simple stats to true on line 74 and so on. And you can feel there's something really awkward about this. From the user's perspective, it's just tedious to scroll through dozens or hundreds of lines of code to find the change points. So one thing experienced developers do, and I'm sure many of you do, is to collect the change points in a section at the start of the program. The script is now more user-friendly. Everything is in one place, and this saves time and improves quality by lowering the chance that a user might forget to change a setting that they should have changed. Writing the documentation is also more straightforward. Even better, some developers might add concise but informative comments to create a self-documenting settings panel. This way, you don't even need additional documentation. And even though many of us may not think about this as a sort of user interface, this is really just a settings panel we see in almost every application that we use. It may not look quite the same, but the goal is really the same: to make things easier for the user by collecting settings in one location that is easy to find, and to explain what each setting does in clear language. The settings panel is what application designers would call a UI pattern. A UI pattern is a template that solves a common user interaction problem. And in this case, the problem is that the user needs a central place to indicate preferences for how the application should behave. Another simple example is using input boxes to set preferences rather than directly editing the code. For example, to continue our example, a file chooser allows the user to select the location of the source data using a point and click interface, rather than having to manually type in the file path. Another example is the yes/no dialog box that allows the user to choose whether to show just the means or all statistics. This eliminates the need for the user to find the relevant line in the code and type in true or false. These dialog boxes are very easy to implement in open source languages like R or Python. And in many cases, it's just a single line of code. To best make use of these dialog boxes, the default option should be a sensible one. So in the file chooser, the default folder should be the one in which the user expects to find the source data file. Also, because users are more likely to click on yes, the yes option should be the less risky option. So if the user is choosing between suppressing statistics or not suppressing them, the yes option should be to suppress. Finally, to enhance reproducibility, the user's choices should be written to a configuration file or otherwise documented so that there's an audit trail. So now I'm going to hand it over to Keegan to take us more through more UI patterns.
Thanks, Wei. You can go ahead and go to the next slide. So we can use even more complex UI patterns, such as full setup wizards that walk users through the steps needed to complete an analysis task. So as an example, let's consider the Data File Orientation Toolkit, which is an open source toolkit based in R, developed by some of our NORC colleagues to help assess the quality of administrative data files. So this toolkit, for some background, generates an R Markdown-based report containing data visualizations, tabular summaries, and guidance on interpreting those summaries of data quality based on several dimensions of the FCSM data quality framework. The instructions for the toolkit tell users to go through a few setup steps, as you can see I've highlighted here. So let's think through how a UI pattern can be implemented here to support code reuse. So you can go to the next slide, Wei. In the original version of this toolkit, users were instructed to edit 2 files. So you can see on the right, part of toolkit.rmd and a comment in there that instructs users to manually edit the name of the file they want to read into that R Markdown document. So users also need to make sure they've either moved the file into the correct file directory as it corresponds to the R Markdown file, or alter the file path accordingly. On the left, there's a setup.yaml file that asks users to go through and define each variable included in the analysis file, as well as the variable type for analysis and the data type. So you can see things like categorical, numeric, etc. So these steps are pretty minimal and easy to complete. It really is a few setup steps, but they require the user to already have a good understanding of the data file they want to use and explore, and complete manual editing steps. So in our updated Shiny App version of the toolkit, if you can go to the next slide, users are instead walked through those steps required in a series of setup steps. So you can see this interface where users can select what file to upload using the file chooser. And then once the file uploads, they can preview that data to make sure it uploaded correctly and see each of the variable names and example values of those variables for themselves. Next, users complete the variable specification page. So if you can go to the next slide, This page provides data and variable type definitions for their reference. So there's a drop-down menu that explains what we mean by data types and variable types. Then for each variable in the data, there are point and click toggles for the user to select the appropriate data type and variable type out of a list, and optionally a date format for date variables. Once those steps are completed for each variable, and again, next slide, the user can confirm their specifications. One back, I think. Yeah, they can confirm their specifications and see a table showing the current specifications of their data. Then from here, the user can continue on to see analyses applied to their data, and the end result produces the exact same R Markdown report that was originally generated from the non-Shiny version of the toolkit. So by using these steps and a setup wizard here, we've removed the need for the user to find and manually edit the relevant pieces, but also more visually walked them through the settings they want for their data file while providing the same exact output. All right, and next slide. Another UI pattern we can consider is a dashboard, where we provide information on the steps that need to be completed in a process and provide an overview of the status of that ongoing process. So the example shown here is a dashboard we created for analysts on a project where we generate hundreds of R Markdown-based reports over the span of several months. Each day, analysts can log in and see the current status of the project. So how many reports are active and need to be run, how many reports are ready for review, things like that. I've covered up some of the actual values in the table here, but for each report, the analyst can see some overview, like the type of study, the cohort, the date it was submitted, its status. They can then click on a specific report in the table. And if you can go to the next slide, then they can go to the report details page and see all the details for that specific report, as well as buttons that initiate each step in the process that's required to generate that report. So for example, you can see buttons to run the matching process for that study, then run all the reports, and then at the bottom, an option to report an error if they encounter an error. So in this setup, users don't have to directly interact with the code at all, or even see what the underlying data look like. The entire process is wrapped up in a user interface that walks them through the steps and applies the correct parameters with no editing needed by the analyst at all. All right, so to the final slide. So to summarize, we can apply UI patterns and write our programs and processes with a structure aimed at users. This can be as simple as collecting the options and parameters at the top of a script, so they're easy to identify and change, or more complex, such as building an actual interactive interface for users to input and change those parameters before producing their results. All of these UI patterns support code reuse because they provide ways for users to apply and adapt code for their own use or on their own data files. But along the way, thinking about structuring each of these processes as an app also provides structure that helps the users understand the code itself if they go look at it, and provide an overview of the process from a high level. Your code does not have to be an app to act like an app. But thinking about programs through the view of how they might be used as an application benefits your organization and reproducibility practices, and makes it easier for others to apply and reuse that code in an effective way. And that's what we've got.
Excellent. Thanks to all of the speakers. That was fantastic. And we nailed it on the time, so we can all pat ourselves on the back for that. So if the speakers could all come back on camera, we'll jump into the Q&A portion. We have 20 minutes. There's been some questions in the chat. Some of them have been answered, but I'm going to ask them out here kind of in the public anyway, just FYI for the speakers that have already answered some of their questions. So starting with June, Clayton had a question. Sorry. There we go. Clayton had a question about when making data open, should agencies or data providers be focusing more on things like making sure data conform to a schema over making the data easier to use, that is, by providing it as a CSV?
I think this is a very good question. Usually, my opinion is that we should stick to some data curation principles. Among the principle easier to use is actually one of them. But of course, to carry out these principles, it can what exactly you do can vary depending on the situation. For example, this if your data set is very small, probably just providing it as a CSV file and including all the columns, and you don't need to worry about some data redundancy issues. If your data set is big, for example, the NYC 311 request data, we have in our work, we have identified there are a few columns that are redundant, completely redundant. And if we remove those redundant information, and then for some variables that are factor or character variables, if we code them, then the size of the data set could be reduced by 20%. And for data set that big, that can be quite significant. The users can spend less time downloading data and less traffic over the internet. And then a lot of the operations can be done on the client side after the downloading of the data, instead of providing from the server side. So in summary, I guess there are some principles. Easier to use should be one of them. And then this could be situation dependent.
All right, thank you. And I'll remind everybody that the Q&A feature is still open. So as we're going along here, definitely put your questions into the chat. And if you could also highlight who the question is for, that would be fantastic. Question for Ben. What latitude do you have for formatting the text in the documentation? So Stas asked about the LaTeX type equations, but what other sorts of latitude do you have for sort of formatting that text and stylizing it?
Thanks, Brendan. So our packages have a kind of minimal component. So you have to always say like what your inputs are, your outputs are. But beyond that, there's quite a lot of flexibility in the kinds of additional details you can provide users. So if you want to provide them like an image, like a screenshot of a formula, or you want to include Roxygen code comments with formulas. Roxygen is a particular R package that lets you easily document your R code while you're programming it. Then there's a lot of flexibility to put those pieces in different parts of your documentation. So something that might be more challenging, like an image file, for example, you can include in that vignette or the longer form documentation. And more detailed text and formulas and stuff you can include pretty much anywhere in an R package, the help page, the README, and so on. So really, there's a lot of flexibility. One particular thing that's worth recommending is you can include a journal article as part of your R package as a vignette that's shared on CRAN publicly. You can put a journal article published in something like the R Journal, Journal of Open Source Software, Journal of Statistical Software. You can take that article and put it with your R package, which is really helpful for documenting the statistical methods. So yeah, there's basically go wild with it. That's what I'm saying.
Does Roxygen accept like Markdown? And if you're comfortable with like directly programming HTML, can you do like complicated things if you want within it?
Yeah, so it's kind of, yeah, I'd say like a Markdown markup kind of language. So there are ways to easily bold things, italicize, that kind of thing.
Awesome. Yeah. So for Matt, the question was about how Beautiful Soup and Selenium compare to Scrapy, but if you could like any sort of tour of the software involved in web scraping that you've done, if you could give kind of like any thoughts you have about why you went the direction you did.
Yeah, originally I was using something called Requests, which is really simple, built to send HTTP requests to websites and return HTML. Switched to Selenium from that because Selenium could handle JavaScript, and we were getting a whole bunch of 404 errors when accessing sites and stuff. But I haven't personally used Scrapy. I'll admit to that limitation of my knowledge. It looks like a great tool that's more dedicated to web scraping, whereas Selenium's just built to mimic web browsers and be for automated web testing. So that's about kind of the succinct way of summarizing what I know.
Yeah, gotcha. And also Clayton asked about it seems like more websites are prohibiting web scraping as part of their terms of service. Is this something that agencies that are doing web scraping should be concerned about?
Yeah, I was looking at answering that one. Short answer is yes, of course, definitely. The real question, to look into it more specifically beyond kind of what I listed in the presentation, is the nature of the task. How big of a lift is it? Are you just trying to get like 1,000 searches done, or is this, because a lot of the cases that I mentioned were companies that were built on scraping another website and using it for their own business? That's different than just trying to automate 10 different searches. For example, there was a case, Craigslist versus something called 3Taps, where they were making a whole other user interface for Craigslist for housing searches. Because I mean, Craigslist is notoriously not the most user-friendly interface. They got a cease and desist from Craigslist for doing that, and then they ignored it and continued until they were eventually sued. So probably don't do that.
All right, and just a reminder for folks to go ahead and put your questions in the Q&A feature if you have them. One more question for Ben from me. So have you found that implementing the software engineering best practices have helped you with interfacing with like those professional programmers that are in like an IT department, or with the infrastructure folks that are going to like take your code and potentially run it on a server somewhere or something? Have you found that that helps with conversations that you have with sort of the professional programming side of things?
Yeah, that's a great question. So a lot of these things are things that I learned from professional developers I work with. So people whose job title might be like IT analyst or like just plain developer. And so it's been helpful when I'm interfacing with the statisticians who want some statistical method implemented, and then the developers who can do that work and build a nice user interface for it. So it's been helpful to use that kind of language with them, that we need like unit testing, or we need integration testing, or these different kinds of things. And for folks like me and a lot of us here who are like statisticians or data scientists first, I think kind of a useful on-ramp to that kind of language is this test that R package, which sort of abstracts some of these different software engineering concepts and makes them easy for our programmers and statisticians, data scientists to learn when we're not like professional developers as our full-time job. Yeah, so that's been very helpful.
And have you found that they're more likely to accept R into like the professional program? I don't know how it is at WestApp, but at least at BLS, like it's something that the statisticians and data scientists do outside of the IT department, and our IT department hasn't fully sort of embraced open source languages just yet, and we're trying to do that with them. And so I'm wondering how this embracing best practices might help.
Yeah, there's these kind of different pockets that we have at WestAt, and I think this is true at a lot of other organizations, where you have like you have folks who have been working in SAS, or maybe it's SPSS or Stata for a long time, and then you've got like some folks who are maybe from recently graduated programs that know R or Python, and that's where they live and breathe. And then you have like these IT analysts who don't work in any of those; they're working in kind of other programming languages. And this kind of language of like testing is really helpful for talking to them. But one thing that I think is really nice about the R ecosystem in particular is CRAN as a resource in this kind of standard R package infrastructure. That's something that other languages don't necessarily have. And it's this huge tool for documenting and testing and making sure all the R packages that people want to use play nicely together. So that's kind of something I think surprises people from this other like SAS, SPSS, what have you camp. And then your traditional like software developers, you're not really used to this kind of CRAN infrastructure, and maybe this this very sort of disciplined like package structure that's enforced. So yeah.
Do you guys have any questions for one another? Anything that you heard in the presentations today you're curious about?
I have a question for Ben. Are you planning to, for the R packages you developed, are you planning to submit vignette articles to the special issue?
If we're invited to, we certainly would. I think long term, what we want to do is publish these on CRAN so that so that we can share our code with our clients who are generally like federal statistical agencies. But then we also want to clearly document the underlying methods and how that interacts with the software in like Journal of Open Source Software, Journal of Statistical Software publications. So those are kind of venues that we're looking at for sharing some of these details.
Yeah, I just want to highlight that the Journal of Data Science has a section called Computing in Data Science. And this section publishes articles similar to those in Journal of Statistical Software, for example. I wrote an article with my former student on Splines 2. And that was the first article. I wanted to use that as an example article just to attract similar contributions. So we welcome articles similar to JSS articles.
Thanks, I really appreciate that suggestion.
Making connections here. Any other questions for one another, or last call for any questions in the Q&A feature?
Yeah, I had a question for Keegan and Wei Hong.
Yep.
Maybe you could talk a little bit about like your experience with, you talked about taking some kind of like R packages and making Shiny apps out of them. I was wondering if you could kind of comment on some of the things that you've noticed that are different in like the documentation or testing between Shiny versus just a regular R package.
Yeah, that's a good question. I would say they're very different in the sense of for a lot of the Shiny apps that we're building on projects, there's not as much of an enforced structure like there is for a standard R package or something you'd be submitting to CRAN. And I think part of our approach is to put on the user hat and think about what users are going to be interacting with the app, both the interface and then in terms of who's going to be maintaining the code in the future. And so thinking through, making a very clear link between spots in the code and their corresponding user interface elements or server elements, making sure that link is very clear and everything's really documented is kind of our general approach. And then there are also, which I'm not as familiar with, but there are also things like the Golem package that let you actually kind of build out a Shiny app very similarly to an R package. It's a very opinionated framework for designing Shiny apps. So you can kind of enforce some structure there. And we do use that on some projects so that your Shiny apps are a little more like an R package. When we're building out a dashboard for analysts, we're not as worried about making it a full-on R package. But for some of the bigger stuff, yeah, we try to enforce some principles of organization and documentation that make it similar to a package.
All right, and with that, I want to thank the speakers one last time. Thanks so much for those great presentations. And I'll give it back to Peter, Wendy, whoever wants to take back over, to give you a little bit of time to do the turnover before the next section starts at 1:25. So thanks again, everybody.